Hey, algebra kids. So we're just going to do a really quick lesson on adding and subtracting polynomials. While we probably haven't called it this before, you definitely know how to add and subtract polynomials, because the whole idea of adding and subtracting polynomials is utilizing distributive property and combining like terms, really. So I'm just going to do a quick review of like terms. Like terms are terms whose variables with any exponents are the same. So what that means is that not only the variable has to be the same, but the exponent has to be the same in order for them to be like terms. So if I look down this list and I highlight, are there any pairs or more than two numbers that are like terms? What would 2x combine with? Hopefully you would say x. Can it combine with the x squareds? No. So I have my 14x squared here that can combine with my minus x squared, right? Or negative x squared. Those two things can be combined. And then I do see one last pair of combined like terms, which are my constants. Constants can combine together as well because they're lacking a variable. They're just regular numbers. They follow regular number rules. Okay, so we're gonna just dive right into a couple examples. So our first polynomial, we have 5p to the third minus 3 plus 2p to the second minus 3p to the third. So we have parentheses around these two separate polynomials, but because we have a plus sign here, we really don't need the parentheses. They can just kind of drop out. All they're doing is just distinctively showing you which polynomial is together, okay? But when we're gonna add them together, we're gonna put it all as one anyways, okay? So looking at our four terms that we have listed here, are there any that can be combined as like terms? So I see right here, I have a 5p to the third, and then over here I have a minus 3p to the third. So those are the only two things that I notify, or like that my brain notices that I can combine. So what is 5p to the third minus 3p to the third? It would be 2p to the third. And then we're gonna write them in descending order. What that means is we always write our highest exponent first, and then we write our next lowest, or the next highest, and then the next highest, all the way down to our constants, okay? So my last two terms I have here, I have plus 2p squared, and then I have a minus 3. And there's my added polynomials. Easy, right? So the only difference with our subtraction is that parentheses do matter when we're subtracting a polynomial from another, because this subtraction is really saying we're subtracting all the terms that are inside here. Now, when I subtract something that has like a negative, for example, what is that going to do? It's going to change it to a positive. So we're going to kind of treat that as like something where we have to do distributive property. So we're going to distribute that minus to the 3a squared and to the minus 4a to the third. So what that's going to change it to is really saying a to the third minus 2a squared minus 3a squared. Now when I subtract, or when I double minus or subtract a negative, it really becomes plus 4a to the third. Now from there, I can just combine any like terms that I see. So I have an a to the third here, and I have a 4a to the third here, and I'm adding them, right? So that's going to give me a total of 5a to the third. I also can combine my a to the second. So I have minus a to the second, or negative, minus 3a to the second, which is minus 5a to the second power. Voila. Okay, so we're gonna beef it up a little bit, add some more terms, but same process counts, okay? This one's adding, so parentheses really don't matter, just look for your like terms here. So I have a negative x to the fourth and a plus 7x to the fourth. I have a plus 3x to the fifth and a plus 5x to the, 13x to the fifth and a 5x to the fifth. It's still early. And then I have a plus 6x to the third and a plus 6x to the third as well. So again, let's talk about which one's our highest exponent. That would be the 5th. So let's do that one first. 13 plus 5 is 18x to the 5th. My next highest exponent is 4, so I have 7x, and then I have a negative x to the 4th, so that would be a 6x to the 4th. And then my last one is my x to the 3rd, which is 12x to the 3rd. Ta-da! All right, last one. One more subtraction with bigger term or more terms, not bigger. Okay, so we're going to just remember we got to distribute the negative to all 3 terms on this one. Okay, so I'm going to rewrite my first polynomial. Now I have minus negative 10a squared, so that's going to become a plus 10a squared, minus negative 11a squared, so plus 11a, sorry, to the 5th. Man, guys, I'm struggling. Minus a positive 9a, so that's going to still be minus 9a. Now I can go ahead and do my combining like terms. I see a 13a squared here, and I have a plus 10a squared there. I see a minus 6a to the 5th and a plus 11a to the 5th. And then I see a minus 2a and a minus 9a. Let's go ahead and put them in standard form. So largest exponent first. So I have negative 6a to the 5th plus 11a to the 5th. That would be 5a to the 5th. Move on to my a to the 2nd. I have positive 13 and a positive 10. So I have 23a to the 2nd. And then I have a negative 2a and a minus 9a. So I have negative 11a. All right, guys. So now you have your not Google. Yeah, it's a Google Slides practice. That's a Schoology assignment. So good luck. Ask us if you have any questions.